So hello everyone. Now let's move into deep learning, where we all will discuss questions related to neural networks and their different types. So deep learning is a part of AI that teaches machines to learn patterns from large amount of data. So let's look at the important concepts and types one by one. So question 17 is, for binomial n equal to 10 and p equal to 0.5, expected value will be. So mm, in binomial distribution, the expected value or mean is given by the formula n into p. So here n equals to 10 and p equals to 0.5. So if we conclude its products, we'll get 5. So this means that if we repeat this experiment many times, on average we expect 5 successes out of 10 trials. So for example, if you toss a fair coin 10 times, on average you will get 5 heads. So the next question is, if r square equals to 0.8, TSS equals to 100, find RSS. So we are given r square, that is r squared distance, 0.8, and TSS, that is total sum of squares, that is 100. So R2 basically tells us how much of the total variation in the data is explained by the model. And we know the relation that r square is equal to 1 minus RSS divided by TSS. So from this we can rearrange to find RSS. That is, RSS is equals to TSS into 1 minus r square, and if we substitute the values, we'll get RSS is equals to 20. So the residual sum of squares is 20, which means the remaining unexplained error in the model is 20 units. Recent update rule uses the term dash for the weight update. So we use gradient descent to minimize the cost function, so which represents the error of the model. So when we update the weight, we use the gradient of the cost function with respect to w. So the update rule usually is w new equals to w old minus learning rate into del z upon del w. So it tells that in which direction the error is increases, and we move on in the opposite direction to reduce the error. So the key term used for weight update is gradient descent, is del z upon del w, the gradient of the cost function. So the next question is, for a normal 0, 1 distribution, what percentage of data lies between -2 and +2? So uh, for these questions, we will be working with the standard normal distribution, which has mean 0, standard deviation 1. So we know the rule 68, 95, 99.7 rule. 68% rule says that the data lies within +1 to -1 deviation. 95.4% rule tells that data lies within ±2 standard deviation, and 99.7 lies between ±3 standard deviation. So between -2 and +2, we have approximately 95.4% of all the data values. So the next question is, for k-fold cross validation with k equal to 5, each iteration uses what percentage of data for training? This means that data is divided into 5 equal parts called folds. So in each iteration, first fold is used for testing and 4 folds are used for training. So training data equal to 4 out of 5 parts. So in percentage term, we can write that training percentage is 4 divided by 5 into 100, that is 80%. So in each iteration, 5-fold cross validation, 80% of the data is used for training and 20% of the data is. So the next question is, compute precision if TP equal to 40 and FP equal to 10. So here TP stands for true positive and FP stands for false positive. So true positive is equal to 40 and false positive equals to 10. So precision tells us out of all the positive predictions made by the model, how many were actually correct. So the formula for precision is TP upon TP plus FP. So after calculation, we'll get 0.8. Next question is, if recall equal to 0.8 and precision equals to 0.4, what is the F1 score? So we know the formula for F1 score is 2 into precision into recall upon precision plus recall. So if we put the values as mentioned here, we'll get the final answer, which is approximately equal to 0.533. So this tells us that when precision is low, that is 0.4, and recall is higher, that is 0.8, the combined performance is medium, around 0.53. Next question is, a model gives TP equals to 70, TN equals to 80, and FP equals to 20, FN equals to 30. What is the accuracy? So the all the values were given, and we know the formula of accuracy is TP plus TN upon TP plus TN plus FP plus FN. So also putting values in these equations, we'll get accuracy value is 0.75. So this means that out of 200 total cases, the model predicted that 150 correctly, that is 0.75. So the next question is, for a Poisson lambda equal to 4 distribution, what is the expected value? So in Poisson distribution, something very important and simple holds, that mean equals to lambda and variance also equals to lambda. So the expected value or mean is equal to lambda. So here lambda equals to 3, so the expected value is also equals to 3. This means that on average we expect the event to occur 3 times in the given time interval or region. So for example, if lambda represents the average number of customers arriving per minute, so then on average we expect 3 customers per minute.